let's do a very interesting question related to remainder theorem. We are going to find the value of unknown which is given in polynomial. Let's start. Find k if x raised to 51 plus 2x raised to 60 plus 3x plus k is divisible by x plus 1. Now, you must be thinking, here there is no mention anywhere about the remainder theorem and not even about the word remainder as well. Then how can we relate this question to the remainder theorem? So first of all, let's write these two polynomials, right? So let's move on with that step. So polynomial is x raised to 51 plus 2x raised to 60 plus 3x plus k, and we are dividing with x plus 1. This is what we are dividing with, right? Now there is a one word given over here that's very important, and from that we are coming to know that it is about remainder theorem, which is word divisible. Okay, let's understand the meaning of the word divisible. If you already know, that's good. Let me help you to recall again. So 7 divided by 2, right? So we can write 2 3s are 6 minus 1 is the remainder. Simple. And let's take another case that 6 divided by 2. Here 2 3s are 6 minus remainder 0. Now here when we get remainder 0, we can say that, right, 6 is divisible by 2. Here 7 is not divisible by 2 because we are getting some remainder other than 0, right? Whenever it is given divisible, what we need to take? Remainder as 0, right? And here remainder will not be 0 if it is not divisible. So generally what we discuss about the previous cases, we were not getting remainder 0. So in that case we can say that those two polynomials were not divisible, right? So here I can say that 6 is divisible by 2, but 7 is not divisible by 2. Simple to understand. If we get remainder other than 0, not divisible. If we get remainder 0, it is divisible. Now come back to the question. It is given divisible by x plus 1. Means remainder will be what? 0. Indirectly it is given that we are supposed to take remainder 0, right? So let's write here remainder is equal to 0 because it is divisible. Now this is how we come to know that we are going to use remainder theorem. So let's start. For that we take the divisor and equate to 0. So let's write here x plus 1 is equal to 0. So value of x will be, if we shift over that side, that's minus 1. Now let's substitute this value into the polynomial. So we can write here p minus 1 is equal to, what can I write? Okay, if you substitute minus 1 into the polynomial, what you should get at the remainder? Get as the remainder. What? 0. That's what we discussed. Why? Because it is divisible, and whenever it is divisible, we get remainder 0. So here we will write 0. Remember, if you are not mentioning 0, you won't be able to get the value of k. Now let's start with this substitution. X raised to 51. So minus 1 raised to 51. Then plus 2 x raised to 60. So here we can write minus 1 raised to 60 plus 3 into minus 1 plus k is equal to 0. Now let's solve this. Okay, that we discussed minus 1 raised to odd power. So answer will be minus 1 plus 2 into minus 1 raised to even power. So even power means what? We'll get positive 1. Now 1 2s are 2 it is. Here 3 into minus 1, that's minus 3 plus k is equal to 0. Now linear equation in one variable. Simple. So here minus 1 and just let's simplify and finish it off. Right, minus 1 and plus 2. So plus 1 minus 3, you'll get minus 2 plus k is equal to 0. So value of k is positive 2. So this is my answer for this value of k. Now let's repeat what we need to understand in this question was about the meaning of the word divisible. It's all about that. Divisible means what? Remainder 0. If it is not divisible, remainder will not be 0. So whenever it is given that it is divisible, we can use remainder theorem and we need to equate to 0. This is the most important part of this sum. If you can understand, then only it will be easy for you to get the value of k. Now let's discuss another question. Let's discuss the case with two polynomials. Previously we discussed the case with only one polynomial. Now we are going to discuss the case with two polynomials and one unknown. Let's see how do we find that. So let's start with the question. If the polynomial 2x cubed plus kx squared plus 3x minus 5 and x cubed plus x squared minus 2x plus 2k leave the same remainder, it's given, leave the same remainder. That word indicates that we are supposed to use remainder theorem over here. When divided by x minus 3, then find the value of k. So first of all, let's understand. We have two polynomials and both of them is divided by single polynomial, which is x minus 3, and we get the remainder in both of the case, and that remainder is same in both of the case, right? And we are going to equate and we are going to solve it. If you are still confused, don't worry. Let's start with the question. First of all, let's start with the first polynomial, which is, let's say, 2x cubed plus kx squared plus 3x minus 5 divided by x minus 3. First of all, we are going to find the remainder. Remember that's the, and let's write second one over here, which is x cubed plus x squared minus 2x plus 2k divided by, what's that? X minus 3. So in both of the cases, whatever value we are going to substitute is going to remain same. Why? Because see, the divisor is same. So we are not supposed to calculate two times. You calculate only one time, that is sufficient. So let's do calculation over here. So we will equate divisor as 0 is equal to 0. So we get x is equal to 3. Now this value x is equal to 3, we are going to substitute in both polynomials one by one. So first of all, let's start over here. So I can write here that p3, okay, and let's write, instead of x cubed, I will be writing 3 cubed, then 3 square minus 2 into 3 plus 2k. Let's simplify. So here 27, here 9, here minus 6 and 2k as it is. So if we simplify here, plus 9 minus 3, that plus 9 and minus 6. So we will get plus 3, and 27 and plus 3, let's write here, that is 30. So 30 plus 2k. So this is the remainder in this case. Now let's find the remainder in the first case. So we can write here q and 3. So wherever x is there, we are going to replace with the 3. So let's start. 2 into 3 cube plus k into 3 square plus 3 into 3 and minus 5 here. Okay, so let's simplify further. Here 2 into 3 cube, that's 27. 27 into 2, that's 54. Here we can write 3 square, that is 9, and k here, plus 9 as well, minus 5. So 9 minus 5 is 4. 54 plus 4, that's 58, plus 9k. Now we have the remainder in the first case and the second case as well. Now let's read the question. When divided by x minus 3, okay, that's given, leave the same remainder when divided by x by 3. It means that we are supposed to equate both of them, remainder is same. This P3 and Q3 will be equal. Remainder is same. This part and this part is equal. So let's do that one. We can write over here that P3 is equal to Q3. So P3 is 30 plus 2k, and here 58 plus 9k. So let's keep this 58 over here and 2k there. So this will become negative and 2k will go there. So 30 minus 58 is equal to 9k minus 2k. So here minus 28 is equal to 7k. That's linear equation in one variable, very simple to do. So let's solve it further. Here we can write minus 28 is equal to 7k. This k will go into denominator. So minus 28 by 7 is equal to k. 7 ones are and 4s are. So what's the value of k? That is minus 4. Very simple to do, but you need to have the understanding of this question, right? We have two polynomials, which is this and this one, and both of them is divided by the same polynomial, which is x minus 3. So we can get the value of x by equating divisor 0, that is x is equal to 3. That being done, now substitute the value of 3 into the both polynomials, as we want to get the remainder in each case. So here we get Q3 is equal to 58 plus 9k. Here we get P3 is equal to 30 plus 2k. Now it's given that remainder is same. Remainder is same. This is the important part. You can get remainder very easily by substituting, simplifying. So far so good. Now you need to get into this idea as well, that both of the remainder are equal. So equate them, get the linear equation in one variable and get the value of unknown, which is k is equal to minus 4. Let's discuss one more question. Let's start with one more interesting question. We are going to find the value of unknown. Let's start. The polynomial px is equal to x raised to 4 minus 2x cubed plus 3x square minus bx plus 3b minus 7 when divided by x plus 1 leaves the remainder 19. Find the value of b. Also find the remainder when px is divided by x plus 2. So the question is very long, no worries. We are going to do part wise. So first of all, let's start with the finding the value of unknown b. Let's start with that part first. So we have px here, that px is equal to x raised to 4 minus 2x cubed plus 3x square minus bx plus 3b minus 7. Very long polynomial, almost 6 terms are there, right? It is divided by x plus 1 and remainder in that case is what? 19. It's given in the question. Remainder is given. So this indicates that we are supposed to use remainder theorem. So let's start with this one. So what we are going to do? Suppose if there is no remainder given, then how would you do that? You equate this divisor is equal to 0, get the value of x, and whatever value of x we get, substitute into the polynomial. That step is going to remain same, right? So first of all, let's start with that one. So x plus 1 is equal to 0. So what we will get? X is equal to minus 1. Now this step is done. Now what we are supposed to do? This value of x we are going to substitute into the polynomial. So here we can write p minus 1. Okay, we are going to substitute this value. Now is equal to what can I write? It means that if I substitute minus 1 over here, I will be getting the answer as the remainder. But in this case, remainder is already given, which is what? 19. So we can write is equal to 19. Remember the case when the word divisible was given. When we discussed the first question of this topic, we have taken remainder 0, right? But in this case, remainder is straightforward given, which is 19. So let's start. Here we are on LHS side, we are going to substitute the value and RHS will be 19. So let's start. X raised to 4. So we can write here minus 1 raised to 4 minus 2 into x raised to 3. So minus 1 raised to 3 plus 3 into minus 1 square, then minus b into minus 1 plus 3b minus 7 is equal to 19, right? We'll get kind of a linear equation. You can see over here only b is the unknown, rest all are numbers. Now here minus 1 raised to even power, so answer is 1. Minus 1 raised to odd power, so answer will be minus 1. Minus 1 into minus 2, minus minus will be plus 2. So plus 2 it is. Minus 1 raised to even power, so again positive. 3 will remain as it is. Minus 1 into minus b, so positive b. Here 3b as it is, and minus 7 is equal to 19. So this b and plus 3b. Now let's simplify. B and 3b will make 4b over here. So let's write simple 4b. Here 1 plus 2, 3 and 3, 6 and minus 7. 6 minus 7 is what? Minus 1. So minus 1 is equal to 19. Let's shift this minus 1 over here. So 4b is equal to 19. Minus 1 will become plus 1. So we can write here that 4b is equal to 20. So b is equal to 20 by 4 1s are and 5s are. So value of b will be 5. That's the value of unknown b. Our first part of the question is done. Very simple, right? We have the value of polynomial, we have the polynomial, then divisor as well, and remainder as well in this case. Very straightforward. X is equal to minus 1. Substitute into the polynomial, remainder is equal to 19, simplify and get the value of b. So this was the first part. Now what about the second part? Let's read. Find the value of b. Okay, that's been done. Also find the remainder when px is divided by x plus 2. Okay, so let's write what we need to do. We need to find the remainder is equal to question mark when px divided by x plus 2. This is what we need to do, right? We have the polynomial. Now in this case divisor is different. Here it was x plus 1. So here we need to find the value of x. So let's start here. We can write that x plus 2 is equal to 0. So what's the value of x? That is minus 2. Okay, so here you need to be careful with one thing. We cannot keep b as it is now. We need to write the value of b as well, which is b is equal to 5 here, right? So when we substitute, we need to keep in mind. So let's start with that. First of all, let's start with p minus 2. So here let's write p minus 2, okay, and p x raised to 4. So we can write minus 2 raised to 4. Then minus 2x raised to 3. So minus 2 raised to 3. Then plus 3 minus 2 raised to 2. Then minus b is what? 5. X is what? Minus 2. Then plus 3b. Plus 3 into b is 5 and minus 7. So this is it. This is what we need to simplify. So let's start with the simplification. Here we can write minus 2 raised to 4. Power is even. Sign will be positive. 2 raised to 4 is 16. Then minus 2 raised to 3. Power is odd, so it will be negative. Now cube of 2 is 8. 8 2s are 16 and minus minus plus 16. Now here it will be positive because power is even. 4 3s are 12, so plus 12 it is. 5 2s are 10 and minus minus plus, which is plus 10, and here 3 5s are 15, and here minus 7 will be there. So let's start with the calculation over here. So 16 and 16 will be 32, 32 and 10 that's 42, and 44, 44 and 10 that's 44 and 10 that's 54, and 54 and 15, let's write 54 and 15, that's 69, minus 7 if we do it, that is 62. Very simple addition was there. So this is the remainder we get when we divide by x plus 2 to this polynomial. So this question was made up of two parts. First part, we need to find the value of unknown, which is b in this case, while we divide by x plus 1, and remainder is also given, which is 19. So we divide it, we have the remainder 19, substitute the values and get the answer of value of b. Then afterwards we need to get the remainder when we divide by x plus 2. So we need to repeat the steps, but this time with x is equal to minus 2. And one more important fact, we need to put value of b is equal to 5 into the polynomial. Otherwise we'll get the answer in terms of b. Then you need to substitute. Better you start substituting at the first step itself. So this is how we deal with the unknown. Let's deal with the one more question. Now let's discuss one more case with the two polynomials and unknown. Let's start. The polynomial 3x cubed plus ax square plus 3x plus a and 4x cubed plus x square minus 2x plus a. Leave the remainder r1 and r2 when divided by x minus 2 respectively. Okay, so we have two polynomials and both of them is being divided by a single same polynomial, which is x minus 2. And okay, remainders are also given r1 and r2 just for the number. And if r1 minus r2 is equal to 9, find the value of a. So there is a one relation given between two remainders. r1 minus r2 is equal to 9. Previously we dealt with this case. In that case it was given that remainder is same in both of the cases. Here it's not the same. Here it's given r1 minus r2 is equal to 9. Let's start. First of all, let's start with the first polynomial. Let's give it a name, px. So px is equal to 3x cubed plus ax square plus 3x plus 5. And another we can write as, what is there? Qx. Let's take qx or fx. Fx is equal to 4x cubed plus x square minus 2x plus a. Now, what about the divisor? It's x minus 2, right? So, as we equate to 0, we are going to get value of x is equal to 2. This is what we are going to get. Now, this value of x we are going to substitute in each polynomial one by one. So, let's start now. So, first of all, with px. So, instead of px, we are going to write p2. So, p2 it is now is equal to 3 into, instead of x, that is 2, and cube plus a into 2 square plus 3 into 2 plus 5. So here 2 cube is 8, 8 3s are 24 plus here 2 square 4, so 4a plus 6 plus 5. So here 24 and 6 will make 30, 30 and 5, that's 35 plus 4a. Now here, see it's given that r1 for the first case. So we can write that's the value of r1. Simple. Now let's do the same for the second polynomial. Here also we are going to take x is equal to 2 only, because we are dividing with the same divisor, which is x minus 2. So f of 2 is equal to, let's write 4 into 2 cube plus 2 square minus 2 into 2 plus a. So here in the second case remainder is r2. So we can write r2 over here. Now 2 cube is 8. 8 fours are, that is 32 plus 4 here, 2 twos are minus 4 plus a here. So 4 and 4 get cancelled. So here it is 32 plus a. Now that's the value of r2. So we have see r1 over here, we have r2 over here. So we have one relation as well, that is r1 minus r2 is equal to 9. So let's start with that relation and substitute the value. Here it is r1 minus r2 is equal to 9. So r1 value is what? 35, then plus 4a minus, remember when you have more than two terms and when you are subtracting, right, keep it in the bracket. That's very important because we are supposed to change the sign of it. 32 plus a is equal to 9 it is. So 35 plus 4a. Now this minus sign here, minus 32, here minus a is equal to 9. So 35 and minus 32, what we will get? Simple, it is 3. So 3 here plus 4a minus a, that is plus 3a is equal to 9. So let's simplify further. Here 3 plus 3a is equal to 9. Let's write here 3 plus 3a is equal to 9. Let's shift 3 over here, that will become negative. So 3a is equal to 9 minus 3, that is 6. So 3a is equal to 6. So what we can write for the a? A is equal to 6 by 3, 3 ones are, 3 twos are. So value of a is 2. This is the value of unknown, right? We learn how to find the value of a from the two polynomials, right? In the case, that case specifically was about the equal remainders. Here we have two remainders, but relation between two remainder is given, that is r1 minus r2 is equal to 9. So we substitute the value of r1 and r2. Remember, if it is minus, be careful about the bracket because you are supposed to change the sign of the both terms. Then solve as the linear equation and get the value of unknown, which is in this case it is 2. So this is how we solve the sums related to remainder theorem and unknowns related to that. Let's move to the next topic.